In the first question, it is given that the angle of prism is 60 degree and angle of minimum deviation, that is delta m, is equals to 40 degree. We want to find the angle of refraction in the prism. Here, when the deviation is minimum, then R1 is equal to R2 and that is equal to A by 2. So the angle of refraction in the prism will be 30 degree. So option 1 is correct option. In question number 2, for a prism with angle of prism 60 degree and refractive index under root 7 by 3, we want to find the minimum angle of incidence so that the light ray refracted from the second surface. That means after refraction, the refracted light ray will be along the surface. For that, the angle of incidence at this point should be critical angle. If this angle is C and this angle is A, then this angle will be A minus C. Applying Snell's law at this point of incidence, we can write N1, that is refractive index of air, so that will be 1, sine I minimum is equals to refractive index of prism is under root 7 by 3 sine of A minus C. So sine of I minimum is equals to under root 7 by 3 into sine A minus C can be written as sine A cos C minus cos A sine C. So sine I minimum will be under root 7 by 3. Sine 60 degree will be root 3 by 2 into cos C. Now the critical angle can be found by using sine C is equals to 1 upon refractive index, that is root 7 by 3. So sine C is equals to under root 3 by 7. So this is root 3 by 2. Cos C can be written as under root 1 minus sine square C, that is 3 by 7, minus cos A, that is cos 60 degree, and cos 60 is 1 by 2, into sine C. Sine C is under root 3 by 7. Simplify this, we will get sine I minimum is equals to 1 by 2. So the minimum angle of incidence will be 30 degree. So option 1 is correct option. In question number 3, the graph of angle of deviation and angle of incidence is given. For the angle of deviation 30 degree, we will get two angle of incidences, that is 30 degree and 60 degree. For angle of incidence I is equals to 30 degree, E will be equal to 60 degree. And for angle of incidence I is equals to 60 degree, the angle of emergence will be 30 degree. We want to find angle of prism. Here delta is given by I plus E minus A. So angle of prism will be I plus E minus delta. If we take I is equals to 30 degree, then 30 plus E will be 60 degree minus, at this point angle of deviation is 30 degree. So angle of prism will be 60 degree. So option 2 is correct option. In question number 4, a ray of light is incident normally on one of the faces of prism of apex angle 30 degree. The apex angle, that means the angle of prism, is 30 degree and light is incident normally on one of the surface. For normally incident ray, there will not be any bending, so it will be incident same. So this angle will also be 90 degree. If we draw normal at this point, if this is 90, this is 30, then this angle will be 60. So angle of incidence on the second surface will be 30 degree. We want to find the angle of deviation of the ray. Delta is given by I plus E minus A. We know the value of I and A. We have to find the angle of emergence. Let's say angle of emergence is E. So applying Snell's law at this point, the refractive index of glass prism is given √2. So √2 sine 30 degree is equals to 1 sine E. Sine 30 is 1 by 2 is equals to sine E. So sine of E is equals to 1 by √2. So angle of emergence is 45 degree. So delta will be I, that is 90 degree, plus E, that is 45 degree, minus A, that is 30 degree. Here the light rays incident normally, so angle of incidence will be 0, as the angle with normal is 0 degree. So delta is equals to 15 degree. So option 3 is correct option. In question number 5, in the given ray of light suffers minimum deviation in equilateral prism P. Additional prisms Q and R of identical shapes are placed as shown in figure. Now what will happen to the incident ray? Here, as this P, Q and R, all three are identical prisms, we can say that these two inverted prisms will cancel out each other's effect. So the deviation will remain same. So it will suffer deviation same as before. So option 3 is correct option. In question number 6, we want to find the angle of deviation when the light is incident at an angle of 45 degree on one of the refracting faces of an equilateral prism, that is A is equals to 60 degree and the refractive index of the prism is 1.414, that is √2. Here we can apply Snell's law, that is mu1 sine I is equals to mu2 sine R on the first face. Let's say this is an equilateral prism. The light ray is incident at an angle of 45 degree. So sine 45 degree is equals to mu2, that is √2 into sine R. Sine 45 is 1 by √2 is equals to √2 sine R. So sine R is equals to 1 by 2, that will give us R is equals to 30 degree. So angle of refraction at this point is 30 degree. Now A is equals to, if this is R1, then this point is R2 and A is equals to R1 plus R2. If R1 is equals to 30 degree, then R2 will also be 30 degree. let's say this E is angle of emergence. So applying Snell's law at this point, we can find root 2 sine 30 degree is equals to 1 sine E. So this will give us E is equals to 45 degree. We want to find angle of deviation, that is I plus E minus E. So angle of incidence is 45 degree. Angle of emergence is also 45 degree, and angle of prism is 60 degree as it is equilateral triangle. So this will give us delta is equals to 30 degree. So option 2 is correct option. In question number 7, a thin prism of 4 degree angle, that is angle of prism is equals to 4 degree, gives a deviation of 2.4 degree. So delta is equals to 2.4 degree. We want to find the refractive index of the material of prism. For the thin prism, the angle of deviation is given by A into mu minus 1. So delta by A plus 1 is equals to mu. So mu will be, delta is 2.4 divided by A is 4 plus 1. So mu will be 0.6 plus 1, that will equal to 1.6. So option 1 is correct option. In question number 8, it is given that a ray of light takes grazing incidence on the first phase. That means this will be the incident ray. So angle of incidence will be equal to 90 degree, and the emergent ray is normal to second phase. That means this is emergent ray and it is normal to the phase. So angle of emergence will be 0. D is the angle of deviation. Then we want to find the angle of prism. The angle of deviation is given by I plus E minus A. Here D is equals to 90 plus 0 minus A. So A will be equal to 90 degree minus D. So option 2 is correct option. In question number 9, the refractive index of a substance of an equilateral prism. So angle of prism is 60 degree and given refractive index is root 3. We want to find the angle of optimum deviation, that is angle of minimum deviation. Here mu is given by sine of A plus delta m by 2 divided by sine of A by 2. Here mu is root 3 is equals to sine of 60 plus delta m by 2 divided by sine 60 by 2, that is equals to sine 30 degree. So sine of 60 plus delta m by 2 is equals to root 3 by 2 is equals to sine of 60 degree. So comparing this two, we can write 60 plus delta m by 2 is equals to 60 degree. So delta minimum is equals to 60 degree. So option 3 is correct option. In question number 10, a thin prism P1 of angle 4 degree and refractive index 1.54, that is E1 is equals to 4 degree and mu1 is equals to 1.54, is combined with another thin prism of refractive index 1.72 to produce dispersion without deviation. We want to find the angle of P2, that is A2. Here, to produce dispersion without deviation, A1 divided by A2 is equals to mu2 minus 1 divided by mu1 minus 1. We want to find A2, so A2 will be equal to A1 into mu1 minus 1 divided by mu2 minus 1. So A2 is equals to A1 is 4, mu1 is 1.54 minus 1, that will be 0.54 divided by 1.72 minus 1, that will be 0.72. Simplify this, we will get A2 is equals to 3 degree. So option 4 is correct option. In question number 11, a crown glass prism with refracting angle 6 degree is to be achromatized for red and blue light with flint glass prism. We want to find the angle of flint glass prism. Given for crown glass, mu r is equals to 1.513 and mu b is equals to 1.523. This is given for crown glass. And for flint glass, refractive index of red is 1.645 and that for blue is 1.665. Here, to achromatize, delta R minus delta B should be equal to 0. That means delta R should be equal to delta B. So mu R minus mu B into A 1 should be equal to mu R dash minus mu B dash into A2. For flint glass, the refractive index are mu R dash and mu B dash. Put the value of mu R, mu B, A1 and this mu R dash and mu B dash. We will get A dash is equals to 3 degree. So option 2 is correct option. In question number 12, the refractive index of glass is 1.520 for red light, that is mu r is equals to 1.52 and it is 1.525 for blue light. D1 and D2 be the angles of minimum deviation for red and blue color. We want to compare the angle of deviation D1 and D2. Here we know that wavelength of R, red color, is greater than wavelength of blue color. D is given as A into mu minus 1, as mu B is greater than mu R. D2 will be greater than D1. So D1 is less than D2. So option 1 is correct option. In question number 13, for a prism, refractive index of violet color is 1.6. For red color it is 1.52 and for yellow color it is 1.56. We want to find the dispersive power. Dispersive power is given by mu v minus mu r upon mu y minus 1. Put the values 1.6 minus 1.52 divided by 1.56 minus 1. Simplify this, we will get dispersive power as 1 by 7. So option 3 is correct option. In question number 14, the angles of minimum deviations are 53 degree for blue color and 51 degree for red colors. They are produced in an equilateral prism, so A is equals to 60 degree. We want to find the dispersive power. Here, for finding dispersive power, we should know the deviation for yellow color, that is delta B plus delta R divided by 2, that is 53 plus 51 divided by 2 is equals to 52 degree. So the dispersive power, let's say capital D, is given by delta B minus delta R divided by delta Y, that is equal to 53 minus 51 divided by 52. So dispersive power will be 1 by 26. So option 2 is correct option. In question number 15, the dispersive power of the material of the prism is 0.0221. Let's say it is D. The deviation produced by it for yellow color, that is delta Y, is equals to 38 degree. We want to find the angular dispersion between red and violet colors, that is we want to find delta V minus delta R. The dispersion power is given by delta V minus delta R divided by delta Y, and it is given 0.0221. So delta V minus delta R is equals to 0.0221 into 38 degree. This will give us the answer delta V minus delta R is equals to approximately 0.84 degree. So option 2 is correct option.